Hello and welcome to this fine episode of the AI Show. My name is Seth Juarez. Pretty excited to be here. Turn that up a little bit. Our official starting music. How's everybody doing? Where is everybody coming from? All right, let's see what we got. I got the chat going here. Let me close all my chat things. I have way too many things open. Let me close all this stuff. Closing. Let's get the chat open here. Where is everybody coming from? I am close to Redmond, Washington, near the Microsoft headquarters. So if you're wondering where I live, don't show up. Looks like we have someone from Maryland. Hello. Welcome, Yolanda. Good to have you. By the way, some of our folks that are going to be presenting today, I record these things beforehand, but they show up to answer questions, so make sure you have your questions here. Let's talk about what we're doing today. Let me share my screen. Let me get my pandemic purchase ready to go. It is ready to go. Today, I am pretty excited. Number one, we're going to be talking about Federated Learning with Azure ML. If you're wondering what language this is, I am too. The next is we're going to be talking about recommenders. I know we've talked about them before, but in this case, we're going to go down to the root level of the actual algorithms and how you can use them too. So make sure you stay tuned for that. That's during the second hour today. This is during the first hour. And then number three, we are going to continue work on Rochambeau. We started to, remember, my Rochambeau project has been taking like 50 years. That's because I literally only kind of work on it when we're all together. And so you're literally seeing me write it live. Every once in a while, I know there's going to be boring parts like getting the SSL certificate to work, and there's no way I'm going to do that on a live stream because ain't nobody got time for that. So today we're going to continue working on that. One of the problems with our AI model is that it only works for me. And it only works for me because all of my training images come from my camera. And so I'm trying to make it so that y'all can go and submit training images as well with rock, paper, scissors, but we got to do it in a safe and responsible way as well. And so that's the part we're working on now. Last time, I think we got to a place where it started capturing images, but we need to save them to storage so that they can participate in the training. Oh, look, Harmke's here. Hi, Harmke from Amsterdam. I feel really bad when people from Europe are on my show because it's like their Friday nights are host. What time is it in Amsterdam? 11, 12, 1, 2, 3, 4, 5, 6, 7. It's like 7 p.m. on a Friday. There's a lot of Netflix to watch. So that's what we're doing today, Federated Learning, which is honestly a very interesting use case that we're going to look at. And then we'll do some work. I also discovered recently something that GitHub puts out. Let's see. Sorry, I have like a screen over here. Something called Primer React, which is like components for React that let you lay out your website a little bit better. And I like the stuff. I'm using Tailwind. Maybe we should. Invariably, any computer thing turns into how you got to write JavaScript and HTML and CSS. So that's what we're also doing. So we'll look at that maybe in between, and also answer any of your questions. This is very much for you all. Andreas from Hamburg. Welcome, my friend. It's so good to have you with us. Pancho Villa is here. Viva Mexico, indeed. Pancho Villa, revolutionary, 19th century from Mexico. Did a lot of work in the north of Mexico. Most of you may not know this, but I grew up in Mexico as a child from when I was 5 until I was 8, believe it or not. That's why I speak the Spanish. That wasn't real Spanish. That was a crappy American accent trying to do Spanish. Okay, so let's see here. Let's start out with Federated Learning. And let's share here the actual video, which, again, is amazing. So without further ado, let's welcome Harmke and Andreas to talk about Federated Learning. Here we go. You're not going to want to miss this episode of the AI Show where we talk all about federated learning with Azure Machine Learning. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about federated learning with Azure Machine Learning. I've got some special guest, Andreas Harmke. Andreas, why don't you introduce yourself and then we'll go to you, Harmke.
Yeah, thank you for having us. So my name is Andreas Kopp. I'm an AI solution architect working with our enterprise customers on interesting AI projects.
Fantastic. Harmke.
And my name is Harmke Alkemade. I also work as an AI solution architect.
Fantastic. So you are the people that actually do stuff with real customers that have real problems. I'm so glad you're here. The first question I thought we'd start with is, what is even federated learning? Why is it important? Who wants to take that one?
Yeah, I brought a couple of slides. So maybe let's first discuss the topic of federated learning, the concepts, and then we can also show a demo. So federated learning is actually a privacy-preserving technology for doing machine learning, which means that several entities, organizations can build a joint model without the need to share any training data for that. And maybe to introduce how it works and what the value is, let's look how machine learning is done today. So assume we have a hospital, a small hospital. They want to develop a machine learning model for predicting the effectiveness of a treatment, for example, or to detect pneumonia. So they can look at the training data which is available. Of course, they have patient data. But in order to really develop a good model, the data needs to be representative in terms of age, ethnic background, gender, maybe medical preconditions. And maybe based on the data, in particular for rare diseases, the model is okay, but not perfect. But of course, this Memorial Hospital here is not the only hospital. So there are other hospitals who have similar data and also similar problems. So it would make sense to combine the data. So an obvious way would really to put all this training data together, to pool it, and then train a joint machine learning model. And you could expect that the coverage is better. It's more training data. It's more diverse. So the overall model that would result from a joint training would likely be much, much better. But if you look in what's happening in reality, it's not happening very often. So there are often compliance concerns in terms of data privacy, or in particular in healthcare, like GDPR or HIPAA, for example. In other cases, there could also be concerns of sharing intellectual property also in other domains beyond healthcare. So this is why pooling between organizations, even though everybody agrees it would provide a lot of benefits, it does not happen. It's relatively rare. And one technology to address this problem is federated learning. So the key idea really to understand is that multiple parties, like multiple hospitals, for example, collaboratively train a machine learning model, but there is no need to share any training data for that. And the way how it works between organizations is there is a concept of a central entity, so a federated server, which hosts a global model. So this is the joint model that all participants train. This global model is distributed to all of the participants, so to the 3 hospitals here in this case. And then each of the hospitals uses only their local training data to train on this copy, on this local copy of the global model. After a training round is finished, each of those hospitals summarize the trained weights, the locally trained weights, send it back to the federated server, to the central server. The federated server aggregates all the weights of those hospitals that have been provided for building the next iteration of the model. Then it's distributed again, and the process continues in several rounds. You can do that until convergence, so until you're satisfied with the overall performance, or you can also use it in a kind of continuous training, which means hospitals are collecting more and more data over time and bring that in, so you have a continuous training in production. That's also possible. But the key aspect really is there is one resulting model which benefits from all the data, but none of the hospitals has to share any data for that. That's the key idea of federated learning.
And what's interesting is it's very reminiscent of parallelizing large machine learning algorithms, but now you're parallelizing over the data in a way that preserves the privacy of the data and the running of the actual models too. Am I getting this right?
Exactly. So there are a couple of options. The central server or the central entity could decide to deploy the model so that it can also be used for inferencing, but you can also do it on a local fashion. But for training, for privacy, the main benefit is that nobody has to share their data. It can stay local.
And the only thing that's shared are, let's just assume, the weights for whatever. Let's just say it's some kind of neural network for vision, for example. It's just the weights that are shared up and then aggregated together in whatever mathematical fashion you want to do.
Exactly.
That's cool.
Exactly.
That's cool. Is there like a use case that you're thinking of that where you're doing this?
Yeah, I mean, it's very dominant in healthcare settings, for example. So we are working with a medical device manufacturer who is testing the capability, for example. And then there are also other use cases when it comes to IP protection. So, for example, a couple of pharmaceutical companies who are actually competitors also developed a joint model based on their very secret source, their IP. So in this case, it was not about privacy, more about IP protection, and even competitors work together in this use case.
That's really cool. All right, so do you have a demo that you can show us?
Glad that you ask. So this is the demo setup. Harmke is going to show you that in a minute. The nice thing, you are able to deploy a global setting across 3 continents within 30 minutes, roughly. So this setup that you can see here is automatically deployed. We are using a public data set, a chest X-ray data set from Kaggle that you can use, so you can try it out without having to provide any data, just to get it working. And in our use case, we are combining 2 technologies. So there is Azure Machine Learning, which is used to provide the necessary compute, also to provide managed data assets, and also to track all the resulting metrics of this federated setup. And we are also using NVIDIA Flare, which is one of the leading tools for federated learning, which is doing the federated learning stuff. And you can think of it as it's a library which takes care of sending all the required training assets to the participants. So the training code, for example. If you want to enhance the privacy level even further, You can add capabilities like homomorphic encryption or differential privacy. It's relatively easy if you have existing training code in PyTorch or in TensorFlow, for example, to integrate NVIDIA Flare. And it also has a nice capability that you can start with a, let's say, simulated environment on a local VM or a local machine before you deploy the whole setup to the real world distributed environment. And yeah, with that, I would hand over to Harmke to show the thing in action.
I love that. Before we get there, so this isn't like theoretical. This is actual stuff that you've deployed and have an example of.
Exactly.
Okay, so we're going to go to Harmke because I think you have some stuff you're going to show us. Is that right?
Yeah, that's correct. I can show how the demo works and maybe also how everyone can try it themselves.
Let's do it.
So therefore, I first want to have a look at the repository. So part of the medical imaging repository on Azure, we have a separate folder for the federated learning solution. And some of the files that we have in here is the configuration files for NVIDIA Flare. I will in a minute share a bit later on how the setup of this solution works. We also have two different applications in here based on the use case that Andreas shared. So it's focused on pneumonia detection using these chest X-ray images, using this public data set from Kaggle. And we have actually two different applications in here. One is a central experiment. So in this case, we do an experiment just with one client or hospital, so we can see how the model would perform using more of a classical machine learning approach. And we also have an application in here where we separate the training over the different clients. So this is really the global federated learning setup that Andreas talked about. And other than these files, what we also have in our repository is two different GitHub workflows. And this is quite interesting because this really supports in setting up all the infrastructure that you would need that runs the solution. And we also have a GitHub Actions workflow that prepares the data set for you, because we are using a normal imaging data set from Kaggle, but we are actually splitting those into three different data sets so we can upload them to the different clients to basically simulate this federated learning environment where every hospital would work with a different data set. So that's on the setup, and then to go a step further.
So before you go there, if I could ask a question there, if you go back to the repo. So in the repo, you basically have this ability to set everything up in multiple geos. So this isn't just like, this is me setting up the exact federated learning with 3 different geos and then the federated part. This will set that up. Is that right?
Yeah, it's correct. So the infra workflow that we have in here will deploy the 3 different machine learning workspaces for you to simulate the different clients, and also the data science virtual machine that we are using as a federated server.
I see. Yeah. So the federated server is a machine, and then there's 3 workspaces ostensibly in different regions where there's training happening, and then it's federated up through that data. Okay, cool. I got it. All right, let's take a look. Let's take a look at it.
Yeah. So what we did to prepare the machine learning workspace to basically serve as a client in this solution is that we, for every machine learning workspace, we have the Europe hospital here, we have the US hospital, and we have the Asia hospital. So those are the 3 different clients that we're working with in this case. And for every hospital, we created a compute instance in the workspace. So this will serve as a compute to train the local model. And this is also, you see that I opened a terminal here in my workspace. I initiated the communication between the server and the clients so that the server can send these training instructions to the different clients. That's basically how the solution works.
I see.
And other than setting up these computes, what we also have prepared in these workspaces is the data sets. So this is what I shared using the workspaces. We basically register a data assets in these 3 different workspaces. So we know for sure that they all have their own private data sets that they can work with. And this is just an example image of one of the chest ray images that we have in the data set.
That's cool. And there's a data set in each region with their data held privately in their workspace.
Correct. Yeah, indeed. Yeah.
That's cool. What else do you like? I'm trying to understand how it federates the whole thing with NVIDIA Flare. That's the thing that's confusing to me. How does that work?
Yeah, that makes sense. So now I shared how we do the preparation on the client side, but now let's go to the federated server.
Got it.
So for that, we're using a different interface and we're actually going to Visual Studio Code. And in this case, you see that I have Visual Studio Code running on my local laptop, but I made an SSH connection into the data science virtual machine that we are using as a federated server. So on this server, we have cloned the repository, so the medical imaging repository with all these assets that we need to set up the solution. And here we see again this project.yaml file, which is part of the repository where we have the configuration of the overall solution. So here, this is part of the NVIDIA Flare setup, and here we can configure where our server is located, and we also define here the different clients that we're working with. So what we're seeing here is the Europe hospital, the Asia hospital, and the US hospital, the 3 different clients. And using this configuration file and an NVIDIA Flare command, we can generate startup packages, and these startup packages can be run both from a server and a client perspective to initiate this communication. So that's basically the preparation. Before you start your training, you first want to make sure that you have the communication established so we can send out the training instructions to the local clients and then send back the locally trained models.
Interesting. So let's see if I got this right, because like I'm understanding it now. You're using the compute instances inside of each workspace as clients and servers, for example, and the federated learning one, the NVIDIA Flare one, sends out instructions to the machines locally. They do the training on their machines with the private data, and they send stuff back to that compute instance. Is that right?
Yeah, that's exactly true. So when one round is finished on one of the clients, so for example, the Europe hospital trained the first version of the local model, then these weights are sent back to the federated server. So the federated server, which is the data science virtual machine, so that's this environment, can then aggregate the different local models into a global model.
I see. And is it like just doing like a linear combination of them, or is it just something that NVIDIA Flare takes care of?
There are different options on how to aggregate the weights. In this case, we're using quite a simple approach, but it's indeed something that NVIDIA Flare handles for us. Yeah.
I see. And how do you set up the communication between the NVIDIA Flare controller and then the rest of the things?
Yeah, so that's using this configuration
I see.
file. We can use a provisioning command, which is part of the NVIDIA Flare SDK. And what is generated is basically different startup packages. So these startup packages can then be copied to the clients, and they contain a startup script. So we can use the terminal in the machine learning workspaces to run this startup script. And then that basically starts the communication from the clients to the server.
That makes sense, and this is fantastic. Anything else you want to show us, Harmke? I feel like you've given us a really good picture.
Yeah, no, this is just about the setup actually. So I also want to show a bit on what the experience would be like for a data scientist who is working from a central perspective on developing these algorithms and then sending out the instructions to the different hospitals. So this is just a quick look at the training script that we have. We are training a PyTorch model in this case. So you will see a training script for a PyTorch model as you would normally recognize it. The difference here is that we're also using the NVIDIA Flare Python SDK in this case to make sure that we can send these artifacts like the locally trained models back to the server. So it's a little bit special, but for a data scientist, this training script would look quite familiar actually.
That makes sense. And if I may, so I'm so glad you started down this line, because I was just so excited about everything that I didn't even think to ask. So basically, your model code doesn't change. For example, I'm a PyTorch fan, as it looks like you are too. You really don't change your code that much for your model. You just
Yeah,
inherit
yeah.
from a different class? Is that what I'm seeing?
Yeah, the network itself and the training instructions, they are quite normal, but there are just some specifics from NVIDIA Flare to make sure that these the different models can be aggregated into one model, for example.
Got it.
So indeed, for a data scientist, it's quite a familiar training script to work with, I would say.
Fantastic. And so how do you put it all together? And so you're going to tell us now. This
Yeah,
is great.
yeah, exactly. Yeah, so after having everything set up and we have developed our training script, then the next step is of course to start the actual training run. So for that, as a data scientist, you could work on a notebook that is in this case also running on the data science virtual machine. And then we can use the NVIDIA Flare SDK to basically create an admin client on our server that can send these instructions to train the model. So let's go through the different steps. We first connect to the NVIDIA Flare admin client running on the server. And then we can use a different command. It's the command check status, just to verify that after setting everything up correctly, that all the clients are connected to our server. So you will see a little table here where we see the different clients.
I see.
And when that they successfully connected to our server. We have 3 clients registered. And this is when we really know that we can start the training. So then we basically submit a training job to the clients. And this is just one simple command, submit job. And you do that with, as an argument, the specific application. So this is like a bundle of files like the training script that I just showed. And these instructions will then, by using this command, be sent to all the different clients to start training. After submitting the job, that's when the training will start. And we also have a command to list the jobs after they started. So here we can see, for example, that at this moment, 2 different training jobs are running for these clients. That's a bit information on how to monitor these jobs.
So just to be clear, because I want to make sure that I'm getting this, this notebook is running in the context of the controlling compute instance in the workspace.
It's a data science virtual machine
Got
in
it.
this case, so it's not running in a workspace. So the clients are running in the workspace. But yeah, this is the controller perspective indeed. Yeah.
I see. Okay, cool. So just to make sure that this isn't some local thing you're running it
No,
on
no.
the data science VM to control the others. Okay.
Exactly. Yeah.
This is awesome. And this is all
Yeah.
available in the repo?
Yeah, this is all available in the repo indeed. Yeah.
Fantastic. Anything else you want to show us?
Yeah, maybe the last component to share. What is interesting is that also from a central perspective, we also have an additional workspace, which is our central workspace. So this is not where the actual training code is running that I just shared, but we are using this central workspace to centrally track the metrics that are generated from the local experiments. So this is quite interesting because even though we are not sharing the data to a central party, we can still send some metrics like the validation accuracy from the local model and send them to one central workspace in this case. So I quickly want to highlight what those metrics look like. And for that, I will compare 2 different experiments that I did, and one is a centralized run. So in this case, we only used one hospital, which is the Asia hospital. And this is where we did the experiment just to check with the full data set, what would the performance be of the model. So this is a bit compared to traditional machine learning because we just sent the instructions from the server to one hospital to train the model. And this is what we can see here in the metric section that we achieved around 96% accuracy. So this is what you would achieve with the training instructions if you would just do a centralized training run. But then we can compare that to a training run that we did on multiple hospitals. So in this case, we have those 3 different private data sets, and we only trained the local models on parts of the data and then aggregated the results. And what we can then see in the metrics is that we not only have the metrics from the Asia hospital, but also here from the US hospital and from the Europe hospital. And what is interesting to see here is that the accuracy, the performance of the model is actually quite similar. So when we have the 3 separate private data sets and then do the federated learning approach to create one federated model, the performance is usually quite similar based on the distribution of the data, of course, to training a central model on the same data set. The difference might be that it takes a couple more epochs to achieve the same performance when we do the federated run, if that makes sense.
So this workspace is a central workspace where you're pushing all of the metrics out of. It's the sink for the okay. And so I don't know. Are you using ML Flow or some other thing to log metrics? You just set this as the
exactly.
Okay, you just set this as the target of the ML Flow. Okay, this is cool.
Yeah,
this is cool. Anything else to add, Harmke?
No, I think that's it.
And well, that's it. She says, yeah, it's actually pretty cool. Andreas, where can people go to find out more about this?
Yeah, there are 2 things I would like to highlight. One is our medical imaging repository, which we mentioned a couple of times. It includes a couple of interesting use cases. Federated learning is just one of them. But if you want to try out Azure Machine Learning for other use cases, take a look, provide feedback, and also let us know what else you might be interested in. And if you are interested in the federated learning part from a conceptual point of view, so what it is, how it works, which aggregation mechanisms are available, there's also this Towards Data Science article that Harmke and I have published, which explains more the background from a conceptual point of view.
Fantastic. And I put those links below so you can see them as well. All I can say is this is awesome. Thank you so much for spending some time with me on this.
Thank you
so much.
And thank you so much for watching. We're learning all about federated learning with Azure Machine Learning here on the AI Show. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? That was awesome, right? Harmke and Andreas are very kind to be answering questions here in the chat. So keep those going. The thing I like about federated learning is the ability to still do machine learning, but in a safer way when it comes to protected data. I think that to me was the coolest part that I was super excited about. And so thanks to Harmke and Andreas on that. I thought it was awesome. And it turns out that when it comes to, here, I'll bring this over so you can see my screen here. Let me share my screen first of all. Because I wanted to look at some of this stuff here. So we saw this recently. This came out, November 16th on Wednesday. Screen of ML. Yeah. Oh, Janiscu number 7. Welcome, my friend. Janiscu number 7. That was for you, buddy. We have this. This came out on Wednesday. Tens of thousands of NVIDIA GPUs, NVIDIA Quantum 2 InfiniBand, and full stack of NVIDIA AI software coming to Azure, NVIDIA, Microsoft, and global enterprises to use platform for rapid, cost-effective AI development and deployment. Yeah, this is cool. We're going to get some more GPUs because heaven knows I can't buy them. Even if I want to. I actually went on there in the meantime while I was looking at like the NVIDIA stuff. You can't even buy this stuff anymore. Like, I'm not even kidding. Like, let's watch. Let me show you what I'm talking about. So I'm going to go to products here and graphics card because, of course, we need the RTX 40 series. See all buying options. Oh, wait. Can we buy the 4080 right now? At Best Buy? Can we? Oh. But what if? What if I undisable it though? Like if I do this, will it make it so that I can buy it? Buy now. Oops. Buy now. Oh, I can buy it now. Hey. Hey, yo. We fixed it. I fixed it. Oh, it doesn't click. Oh, no. Can't buy it. Let's go to 4090. Oh, my. Also sold out. Can't buy these things anywhere. Let's compare them. So I already did. I was comparing them because I wanted to see. So compare. Compare. Come on, click the button. I can't even compare the out of stock ones. Help me. I'm gonna refresh the page. This is just I'm doing too much. There we go. When we look at the two, the 4090 and the 4080, I mean, this is pretty beefy. You remember I have, let's see, which one do I have here? Let's see, task manager, performance. Yeah, there's my GPU. It's the 3080. It only has 64 gigs of RAM. Wait, hold on. Wait a minute. Yeah, see? 64 gigs. What? That's more than this. But maybe that's shared GPU memory. I don't know. It's 48 Celsius right now running. And you can see that it's doing a lot of video encoding. By the way, this is how much RAM I'm using. If you were wondering, I have never got this thing to use more than like 30 or 40 gigs of RAM. Ever. So it may be that you do not, in fact, need 128 gigabytes of RAM. You just may not need that. Maybe. Okay. But yeah, we teamed up with them. NVIDIA today announced a multi-year collaboration with Microsoft to build one of the most powerful AI supercomputers in the world, powered by Microsoft's Azure's advanced supercomputing infrastructure combined with blah, 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 blah. Nice. So I don't have any more details than this because they don't tell me. The other thing I wanted to show you was NVIDIA Flare, which is what Harmke and Andreas were showing us. NVIDIA Flare stands for NVIDIA Federated Learning Application Runtime Environment. We always try in the sciences to make it so that our acronyms are super cool. NVIDIA Flare stands for Federated Learning Application Runtime Environment. Sounds so much better when I say it like that, you know? Is a domain-agnostic open source and extensible SDK for federated learning. It allows researchers and data scientists to adapt existing MLDL workflow to a federated paradigm and enables platform developers to build a secure, privacy-preserving offering for a distributed multi-party collaboration. I should I should do voiceovers for a living. That's the first time I read that. Did you like that? It sounded like a commercial. It looks like it has some cool stuff in there, so make sure you check it out. And finally, the thing that we wanted to look at the most was aka.ms, practical federated learning. Let's go to that. Boom. There's Andreas. Nice dude. And Harmke. Awesome person. You can read about all of this, which is pretty cool. So make sure you go through all of that. This was actually really helpful. This diagram was super helpful because, like, for example, there's certain X-ray data or whatever these are. I don't know if this is X-ray or whatever it is, that you cannot share because of various legal reasons. And so it's cool that you can now federate the learning that way, which is real cool. And there's the examples are in there, which is fantastic. So make sure to check those out. But in the meantime, we are 18. Let me give myself a timer for 18 minutes. Timer for 18 minutes.
18 minutes, counting down.
Thank you. my digital butler. So that at the top of the hour, we're going to continue our machine learning and AI fun by looking into recommender systems. So we'll make sure to get that going. Let me remove. Oh, no, don't want to remove that. Okay. So let's get back to our project here. I'm trying to remember. Let me close the window here and let's open up Hell Rochambeau. Here it is. Let me move my camera. I have multiple cameras. Let me move this camera so that I can. I think last time we were making pictures. I'll move myself to the bottom here, boop, so you can get a better view of all of this. LS CD Web LS Yarn Dev local host, and we're gonna do this thing. Hey yo, howdy doodle. Awkward. That's better. Although, if you're looking at the distribution and the probabilities, it's not good. So we recognize that all of us, that our model is not good, and it's not because we didn't try real hard. Because we did. It's because we don't have enough data. The model's trained on like 300 pictures of just me. Where is this at? Web. No, AI. Data. These are all the images we have. So let me reveal this in Explorer. Reveal in File Explorer. Let's see. Let's just do a properties in here. Yeah, I got like 360 images over 4 categories. So it's not going to work. And so that's the problem we've been running into. So we need more data. More. What was that thing that... Remember Johnny 5 is Alive, that robot? Need more data. That's what it needs. It needs more data. And so we decided to build a thing that will collect images in a responsible way. So let's go to pages. I think it was train. There we go. Hey, yo. And we figured out a way to do the training. So let's bring this up here. Train. Nice. And then we did this, and then we'll capture. And then if you... Oh, whoops. I remember now why it wouldn't do that. Okay, the other thing we need to do is we need to make these flow across, which is nice. So let's get to it. And then when my butler tells me it's time to talk about the other stuff, we will. Okay. The other thing here, let me get to this too. The other thing is I like Tailwind. I do. But I found this. Has anyone seen Primer? Design, build, and create with GitHub's design system. Primer was created by GitHub, for GitHub by GitHub. We love it so much, we chose to open source it to allow the community to design and build their own projects with... Is it Primer or Primer? I wish I could do a poll. Primer or Primer? Which one sounds better? Primer sounds like something you put on before you paint your house. And the framework is actually quite good. Like, for example, it does all the Flexbox stuff, grid layout. But the thing that I liked about it the most is the components. The components are quite nice. These are nice. I don't know. I feel like I've changed. Themes so much. It's like, come on, Seth, please don't do it again. But these are cool, right? like the box stuff makes sense to me. I used it the other day for something. I don't remember what it was, and it was really nice. So maybe we'll consider fixing that. I might do that. But in the meantime, let's actually get some work done here, and let's see what we got going on over here. Let's remind ourselves, shall we? Training. Welcome to training. We had the thing. Set video ID. We got that. Video ID. Gestures. Span. We're going to do flex here. Not glex. Flex. To make that a little bit better, we can close this now. Where did I put that? Did I close it? I might have closed it. Localhost 3000. Oh no, I'm train. Gotta leave that open. And then boom. Oh wait, I did that in the wrong spot. That's not what we wanted. These are the gestures. We want this to be flex. So then capture, inspect. There we go. Inspect. Image. There's the div. I wonder what happens if we put the... There's flex auto in there. Let's see here. Flex. I think it's flex, but I never remember with this. Nope. Oh gosh, this is why CSS is so frustrating. We want the stuff to be all right, we're gonna have to go to Tailwind CSS and figure this out. Okay, Tailwind CSS. Okay, docs. Here we go. Docs. Core concepts. Layout. No. Object fit. Here we go. Flex basis. Flex wrap. Flex. You guys don't have flex items with grow and shrink. Flex. Grid template columns. So this is going to force us to have to do columns, but I don't want to have to do columns. Let's see here. How many could we reliably fit in here? 1, 2, 3. I think we could do 4. So let's try that. If we're going to do columns, we can close this. Well, maybe there's something else we can do. Grid auto rows. Let's try this. Maybe this will do it. I bet this is like how CSS works everywhere. It's like, we don't know what we're doing. Maybe this will work. Okay. Boop, boop. Isn't working. Why does it not do the right thing? Okay. Oh, this is rows. Maybe there's like a auto columns. Here we go. Let's try this. Let's try this. Yes! That was a disturbing laugh. I feel like oh man. Oh jeez. Oh man. I did my villain laugh too soon. My villain laugh was too soon. You know, it's unfortunate when you get your villain laugh too soon, because then you get overflow problems like this, and there's no coming back from that, right? Okay, grid flow call, auto calls min. Let's see what happens to that. Nothing. Refresh. The right music is playing for this, though. At least we got that going. Let's see if there's a wrap function. Let's see. Wrap. Rappy rap rap. Grid autoflow. Okay, let's read this. Utilities for controlling how elements in a grid are auto-placed. Use grid flow keyword utilities to control how auto-placement algorithms for a grid layout. Grid flow column. Let's do that. That's what we did, I think. Let's take a look. Maybe if we do take this off. And then go back. Yeah, that's weird. We don't want that. Let's do this. Let's make it so that it only fits 2, 3, 4. Let's do 4. 4 at a time. We'll do 4. And then that way it's forced. And then if it, hopefully it'll auto flow. Oh, what about auto calls auto? Auto. Let's see that. That's like, it has auto in there twice, which means it's has to work. It's because it's like, oh, jeez. Oh, my gosh. Oh, my goodness. Oh, my gosh. Why? Let's do rows. Nope. Gosh, why it like we have made some like seriously amazing AI, and I'm sitting here like I can't get the stupid thing to work. Okay, let's see. Let's just force the grid to be a certain size here. Grid auto flow. I don't even know what these mean. Let's try auto. Nope. No, jeez, why is this so dumb? That's it. I'm not spending any more time on this. We're going to make it work by being explicit. Let's see. We'll do 4. Yep, that's what we wanted. Okay, cool. Now we need to find a way to make it so that when I do that, it doesn't kill all of them. And then we need to have a submit button right next to it. Okay. Okay, uh-oh. Yeah, that's a problem. Cool. So we need to find a way to key these a little bit better. Yeah, there's notice key 12 is in there. Okay, cool. All right, let's go back and figure out what's going on. So anytime we click on them, we need to remove them. So when we add an image, we set the image to whatever's in there plus the next thing. And the image is going to have a key, an image, and a label. Okay. And it looks like the key we're giving it is the actual name. But the problem is if we remove them, we'll have to rekey all of them, which is what we don't want. So let's take the key off. Let's take the key off. So that's not what matters. And then what we'll do is when we do this, we have to do, instead of a map, maybe there's a map that passes the index to JavaScript map with index. Hold on, let me move this. JavaScript map index. Here we go. What do we got here? Array.map. So it looks like we have the map can be the element, the index, and the array. So we can do this. This could be I. This could be I. And then what we need to do is we need to splice out I. So remove an image, we set the images to a splice, and it returns a number or undefined. Let's see. How do we remove an element from an array? Okay, let's see here. Remove index from JavaScript array. Okay. So this removes from the end splice. This, oh shoot, it's already been 18 minutes. Hold on, we'll figure this out. Splice to remove elements for a specific index. I see what we're doing. So the splice takes the element out, but okay, I see what we're doing wrong. So we need to splice it. We'll do console.log removed. I think you can do F strings. There we go. Very nice. Then we splice it. Oh, no. That's what we do. Const removed equals this. Then what we can do is we can do R. Then we can set images to images. I think that will work. Let's try it. Okay, let's go back to this one. We'll refresh here. Doot. Okay, there's the keys. It's not removing it. Yeah, this is an object, so we'll just say key. And then once we've removed it, though, see, this is a problem because it's storing it here. Let's try this. Too many of these. All right, let's see what happens because this deconstructs the array into this thing. All right, let's take a look here. Okay, let's clear them all out. So it looks like it's working. But let's do this. Let's do a rock, a paper, a scissors, a none, a rock, a paper, a scissors, a none. All right. So if I remove scissors, we should have paper and none left. Paper and none. Perfect. If I remove a paper, we should have rock and scissors left. We do. If I remove a none, we have this and this. Okay, it's working. We did it. Nice. All right. That is delightful. We're doing a thing. Now, I think it's time for us to talk about recommender systems. I'm pretty excited with Miguel. He is a wonderful dude, and you're going to love what he has to share with us because it is immediately actionable for you all to actually just use this stuff. And it's a repo. It's great. So let's give it up for Miguel and recommender systems right now. You're not going to want to miss this episode of the AI Show where we talk about building recommender systems with my friend Miguel, who lives in beautiful Spain. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about building recommender systems with Miguel. Miguel, how you doing, my friend?
Very good, Seth. Thank you for having me.
Fantastic. So tell us about yourself. What do you do?
So I'm a data scientist. I've been working on different areas in the company. I started in Azure, and recently I was moved to Xbox, to gaming.
Fantastic. So recommender systems, tell us the details.
So you see, Seth, I feel like there is a massive opportunity, that never happened before in history until now, and it's about recommendation systems where we can really build a strong relationship with customers, right? And think about. I was thinking about this quote from Henry Ford, and he's one of the biggest innovators, and he was saying, you can have a car of any color as long as it is black, he said, right? And this is actually pretty similar to what we have in the internet right now. Like all the pages are the same for everyone, and if I feel like we this quote was from 100 years ago, right? And now in the internet we have the same thing. And then on the other hand, we have the a personalized service, which is what you get when you enter a store. And I remember a story when I was going to get married, so I had to get a suit, and I went to this store, and there was this guy, and he looked at me like this, and then he said, "This is the size." And then he grabbed a suit, and I tried it, and it was perfect. And it was so perfect that I remember I was with my father, and I said, "Okay, let's try another one." And the guy brought another one, and it was like, no, it was the first one. So the guy was amazing, right? And and we were out in 30 minutes. But the thing is, this is the perfect personalized experience, right? Like you have in a day-to-day. But this person can only get, I don't know, 10 or 20 customers per day, maybe, right? So with recommendation systems, the idea is we can scale to thousands of customers, right? And obviously, our recommendation system is not as good as a real person, but maybe it's something in between. Like you can have any color you want as long as it's black, and
Right.
the perfect experience, right? So like that's, in my opinion, that's an amazing opportunity. And something that I was thinking that Satya, our CEO, says is, he talks a lot about empathy, and empathy in the sense of understanding the customer, right? Like he has this quote. He says, like, our job is to meet the unmet, unarticulated need of our customers, right? That's what, like, unmet, unarticulated. So somehow an AI solution is something that we can understand the customer, and we can give a better service. So that's the first opportunity that I think is amazing. Now the second opportunity is the economic opportunity, right? So we have a very difficult economic situation, high inflation. All companies are cutting costs, and we live in an environment where we need to do more with less, right? And obviously AI can help in the productivity, but we like, if you think about AI, we can do two things. We can either increase the revenue or reduce the cost, right? Now, the thing is, there are many AI solutions that reduce the cost, but and you can think about medical imaging, like to make a better use of doctors, things like data content generation, like DALI and all these image generation that we're seeing that are amazing. Things like GitHub Copilot. I know you're a super fan of GitHub Copilot. This is reducing costs, but you always have a limit, right? But recommendation systems, for example, you can actually increase the revenue, right? And that's the key. There is a famous report by McKinsey around 10 years ago. Actually, they mentioned that 35% of the revenue of Amazon.com comes from recommendation systems, and 75% of what people watch on Netflix comes from recommendation systems. So basically, in my opinion, if you're in e-commerce, if you're in media, and somehow you're selling to B2C, to customers, you need recommendation systems. So that's these two perspectives, I think they are quite interesting.
And I love that, like, the two perspectives, and it sounds like you can have your cake and eat it too. One, you're getting a better experience for your customers, and two, because you're getting a better experience, you're increasing, hopefully, revenue. It sounds too good to be true. How does someone go about doing this in a reasonable way?
So the creating recommendation system at scale is actually pretty challenging, and my team, for the last 4 years, I think we have built this repository called Microsoft Recommenders. It's an open source repository where we help people build recommendation systems on Azure, right? And we have here the repository. I'm sure we are sharing we see the
Yep.
screen right now. Now, I would like to quickly talk about the three main components of the content that we have here. The three main components are the test, the library, this is the library, and the examples. Now I'm going to start with the test because, one of the biggest challenges for us is being able to maintain the library, and also being able to make a library robust enough so when people download the library and start using the library, it works. And that's very, very challenging. So we have a very advanced test infrastructure, and everything is here in this the content. We have multiple categories of tests, and actually this test, this category is something that we work with many different people in the company. So it's not only our team, so it's people from Azure, people from Microsoft Research, and many other people. So we have like different kinds of tests. So we're trying to really make sure that we cover all the scenarios, right? Things like unit tests, data validation to make sure that the data schema is right, functional tests to make sure that the machine learning works correctly, integration, like making sure that different components in your Azure pipeline works correctly, things like performance tests, so making sure that the solution is performant in terms of computation time and memory, and it doesn't change, it's always bounded. Responsible AI test, this is something that I'm super excited about, like how we make sure that we are enforcing fairness, transparency, explainability, and we are working with the explainability of fairness team and Microsoft to make this happen. Security, which is massively important for us. Actually, the security, we have the dependencies. One of the most difficult things in this library is the dependencies. So we need to make sure that all the dependencies are secure and pass the standards of Microsoft. So really a lot of different tests. Right now we are running around 900 tests per day.
Wow.
And here you can see, here you can see some of them. So we have some tests that I execute when there is a pull request. These are the unit tests, and then the nightly builds. And here you see that we have 3 environments: the CPU environment, GPU, and Spark. And here's, for example, this is just one example of some of the tests. You see here it is a good number, and you see the different Python versions. And one interesting thing that we're doing, and this is very recent, is that we wanted to scale this set of tests. And at the end of the day, this is an MLOps platform, a massive MLOps platform that tests everything, right? So we are using AzureML to distribute tests on different machines. So for example, here what you see is a group of tests. You see that this is actually a file and a specific test. And this is going to one worker, right? And the different, there are different groups. So different groups go to different workers, and then each of them execute different tests, right? So basically we are executing everything in parallel to make sure we are reducing the cost, which right now is very important, and we are going faster.
That's cool.
So this is the test suite, which is really interesting. Now, the second thing that I wanted to talk about is the library per se. Let me close all these things. And the idea is the main principle is we want to make this very simple and very easy for people to use, right? So if you look at the content, it is very simple, right? Like we have actually, like these 5 folders, and everything is there. So here we have everything related to data sets, how to load the data set, how to download the data set, and actually different data sets that we use. Evaluation is how to evaluate, like in recommendation systems, the evaluation metrics are kind of different in comparison to other AI solutions. We have the models, like all the machine learning models that we build. In the main page, in the main README, there is a large list of all the different models, and with a description and example. Some of them are external models and algorithms done by the research community, and then the ones that have this star are done by Microsoft, maybe by my team, or maybe by some partners like the Microsoft Research, that we work a lot with them. So here you see we have around 20 different algorithms on different environments. So yeah, that's the second component. And then the third component is the examples. And I think this is probably the most interesting component for people that want to learn about recommendation systems and they want to build. And is a set of examples using Jupyter notebooks. And basically we have 2 kinds of examples. So what we call the quick start examples. And for example, here, this is one algorithm that is pretty simple, is very fast. Is one of the algorithms that our team developed. And the idea of this quick start notebooks is a very quick way of showing the algorithm. So we use one data set. Here you have the example of data set. Then we train, we do split and train and test. Then we instantiate the model, we train the model, predict, and then compute the metrics, right? It's very simple. If you want to start, if you are starting on recommendation system, you can bring your data here, execute this algorithm, and it should work, right?
This is really cool. I mean, sorry, you were going to say, I just want to mention, so in this repo, you have the tests that show the thing is solid, the models that you can use, and there was over 20, half of which your team or folks at Microsoft had built. And then you have simple notebooks that show you step-by-step process how to use them. Am I getting this right?
Exactly. That's the key idea. And I feel like this is one of the reasons why this library has been so successful. And actually, there was something amazing that happened last week, actually. For the first time, this library is the top rated machine learning library at Microsoft on GitHub. We surpassed LightGBM. LightGBM is actually a boosted machine library that we also did.
It's an important one.
Is very good. Is in my opinion, LightGBM is a piece of art. So for people that are in AI, LightGBM is I mean, like a piece of art. It's fantastic. And being at the same level as LightGBM in terms of popularity is an honor. It's an absolute honor. So we're super happy.
Fantastic. So this is something that you use during your daily work and other people at Microsoft, and now you're hoping other people will use it as well. Is that right?
Yes, exactly. That's a lot of people internally at Microsoft are using it, different teams, but also we worked with external teams using this repository, and actually we from time to time we heard people that they use the repository and we don't even know, because this is an open source repository and anyone can take it. And it's funny because sometimes I get an email, a message from LinkedIn, and it's like, "Hey Miguel, I'm using recommenders. It's super cool." And then they may ask you a question like, "Hey, how can you help me on that?" And I think it's really, really, really interesting. It is from Microsoft point of view. I think Microsoft is providing a good thought leadership. Providing open source code so people can learn. And also, even for our customers, is good because we are creating content that is useful to these customers, right?
I love it. So if folks want to get started with recommenders, what is your suggestion? Obviously, go to the repository. We're gonna put a link on there. But what would be your go do this to learn stuff? What would you tell people to do?
Well, so my advice is, in my experience, when I create AI systems, the best strategy is to start from something that works. That's the key, right? So instead of creating something from scratch, which is what everybody does, it's actually I will do the opposite. I will go. This is what I will do. I will go to one of the simple examples here. Just let's take this one, and I will make sure it runs in my computer. It should run because again, we have these 900 tests, so it,
Right.
it should run, right? If it is not running, just let me know, but it should run, right? And then make sure that it runs. And then what I will do is I will come here and I will remove this data set and I will put my data set and see if it works, and then build from there. Start from there, because this is probably, and the interesting thing is that if you follow this pattern, suddenly you have around 20 different algorithms that you can try, right? So suddenly from not having anything, you'll have a massive suite of different algorithms that you can try. And even this is just for the machine learning, and we just talk about the machine learning, but for example here, if you want to operationalize this and deploy this model, so we have examples on how to deploy this model on Azure, right? So here, this example, for example, if you want to create this, here's one example. You have different Azure services, and actually this notebook has two ways of deploying. One is the batch mode, where basically you store all the recommendations in Cosmos, and then if you want to provide the recommendations, the only thing you do is you do a select. So it's basically given an ID, give me back the store the requested output, and is like this. You see? So given the ID, I'm just doing a query to Cosmos, and I'm returning the list of items. This is what is called the batch architecture.
That's cool.
And then the other one is the real-time architecture, when you can load the model in memory and you can score the model in real time. And well, there are several differences, but here you have a very in just one notebook you can use it to deploy your machine learning model and put it in production.
I love the advice of, hey, start with something that works, like take a notebook, run it, and then start putting your data in it. This is amazing. Thank you so much for being with us, my friend.
It was awesome to be here.
Awesome. Well, for those that are watching, make sure you go to the repository. I'm putting the link below so that you can take a look at it. We've been learning all about building recommender systems with Miguel, who has made a wonderful repo that I am going to go and play with. Hopefully you will too. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? I pushed the button too many times. Miguel was awesome to have be on our show to talk about recommender systems. There's a couple of questions in there. The first question here from Chinedu: would I need to have any development knowledge to be able to make use of this system? Some. Here, let me share my screen again here. Boom. Let me move this so you can see me. I'll go to the side here. Would I need to have any development knowledge to do this? So the recommender system thing is right here. I brought it up. And the cool thing is that it has, like, it shows you how to prepare your data, but you do need to have some knowledge of how to do that. And then you can get into collaborative filtering. Here are all the collaborative filtering algorithms. You can see Cornac Bivet Deep Dive, which is a bilateral variational autoencoder, which is cool. And I wonder if it does autoencoding. Let's see. Yeah, looks like it creates a projection space, and then I'm wondering if it does the similarity rankings on the projection space. It does. But yes, you do have to have, apparently for this one, you need to have some math and it's really tiny. Like, I'm looking at my screen, this is really tiny. So let me show it to you. So he basically shows you the math. Looks like the inference model is this. The starting point of VB, so there's a tractable inference model Q governed by a set of variational parameters V, which will be used as a proxy for the true but intractable posterior probability, which is over here. A variational distribution which breaks the coupling of beta and theta, a main source of intractable error, is chosen as blah, with Q being the product of the probability of theta U given RU. Without loss, the following forms are adopted. And then here's the loss function, the expected value, multiply the expected value of the log probability to make these the sums, minus the KL divergence of these particular distributions. Now, we could get into this, but I probably wouldn't. It would take a lot of time. But basically, looks like you do have to know some development and probably some math. Let's see if there's other light GCN, simplified GCN model, graph convolution. So it looks like he's got all sorts of cool stuff in here. Wow. Like, the level of explanation in here is pretty amazing. So it looks like these are all embeddings of each of the items. Looks like they're summing stuff out. They're using a leaky ReLU. To obtain a final, each propagated embedding is concatenated, and then the final user's preference over the item is computed as the dot product. This is bananas. I mean, this is really good stuff. This is cool. And then there's the answers. This is really cool. So not only does he have, and I didn't even know this, not only do they have in this the actual notebooks, but they have the math explanation of this stuff, which is pretty cool. What else we got? Collaborative filtering. There's content-based filtering. By the way, if you're wondering what's the difference here, let me, because I'm looking at this and I'm like, wow, this probably feels really complicated. So let's talk about content-based filtering first. Here, oh, I have like a whole chalkboard for this. Oh yeah, we're gonna use the chalkboard. Here we go. Because this question's an important one. So let's talk about a content-based filtering. Here, we'll do red pen this. We'll do content-based filtering. Content-based filtering. So the idea is that if you have, let's just say you are interested in items like these, that look like this. The idea is that if you like these kinds of things, then you will probably like this thing, because even though it's a different color, it has the same kind of internal representation. So the idea with content-based filtering is if we can project these things into some kind of number, like a vector, for example, then what we can do is when this thing comes out in its own vector, there's got to be some mathematical way to measure, how close are these things, and then return the n closest things. So that if a customer is like, ooh, I want this thing, I want this thing, we could automatically look at the distance between these vectors and add it. Notice that this is primarily based on content, on the actual content of the item. So that's content-based filtering. Collaborative-based filtering is interesting because it does something. It's unfortunate that content and collaborative is all the same. So we're going to say content in here. And collaborative-based filtering is kind of the same, but different. So instead of having things, you have people. You have a lot of people, right? Here's all the people, and then here's you. And what we do is we try to convert these people into vectors, right? Vectors. This is an example of content-based filtering, but there's other ways to do it, right? You can do a decomposition. What's it called? So you do the what's it called? It's not like an eigenvalue decomposition, because you can't do that on non-square matrices. It's something else, but I forget what it's called. So the idea is that once you convert these things to that, as you're adding products to your bag, if you are similar to this person because of this vector, then we'll look at these products that they also like and we'll add them to your bag. That's collaborative-based filtering. So it's a cross product somehow of the things that people like that are similar to you that you'll also like. So that's collaborative-based filtering. And so when you're looking at these things, that's what those two things are. One is for collaborative-based filtering that has to do with people and things. Content-based filtering has to do primarily with the things. Like if this thing is like that thing. My sense is that collaborative-based filtering might get you more bang for your buck, because there's like, if you're gonna buy like hot dogs, showing you all the other hot dogs is not really helpful. But if someone else like you that buys hot dog and likes relish, showing you relish would be useful, even though relish and hot dogs have nothing to do with each other. And so that's why collaborative filtering is kind of awesome. But you could also do a hybrid of both, and looks like they have hybrids, which is cool. Let's see. But yeah, there is some mathiness to this. Like there's some of these that I haven't seen before that I'd have to look at. But matrix factorization for collaborative filtering. Yeah. So Q transpose P I think Q and P are the latent factors for the item. And what you're doing is you're taking the decomposition of that thing with regularization. Nice. This is cool. And you can see you can try this all out. I think this is genius. I wish he was here, but he lives in Spain. And right now it's 12, 1, 2, 3, 4, 5, 6, 7, 8. It's like 9 p.m. And I'm totally not going to use up his Friday night on that. All right. So that was collaborative-based filtering. You have the actual link. Let me go back to it. GitHub.com. Microsoft recommenders. All of that is in here. It's cool. Whew. Alrighty. Now back to our project at hand. Let me set a timer here for timer for 23 minutes.
23 minutes. Counting down.
Thank you. Thank you, my butler. All right, back to Rochambeau training. So we got to a place where it captures these things. We just need a submit button. And maybe we can clean this up a little bit so that it doesn't look so ugly. We also need to put some disclaimers in here. Also, it'd be nice if I hit capture, if it would just take multiple images instead of having to hit each button, or if I hit the space button, it would capture it. Let's do that. Let's do it if we hit the space button. JavaScript on key event React. This is like really old school React too. Yeah. Oh, I see what they're doing. Why did they do this, though? That's weird. You could have just... That feels like a lot of extra stuff. Let's go here. And let's just do it on the entire... let's do it on the entire div. What the crap? Go to definition. Okay. is composing. What the heck? React. Every time it's like, what? Huh? Here we go. Tell us how to do it. Tell us how it's done. Gosh, man, I wish they would just show the code. Sometimes I look at this stuff and I'm just like, oh my goodness gracious. I know. This stuff is just... Oh, I know what I did wrong. It's this. And now you're unhappy? What is this? The type is not assignable to keyboard event handler. The types of parameter event and event are incompatible. Type is not assignable to type. Oh, keyboard event. And then this guy is not happy. Jeez. Oh my gosh. Sometimes, you know, I wonder when we thought like, oh, I wonder if we could make web development even harder somehow. That's what we all decided as a community in technology. Here, let me put my face at the bottom. No, that's not. No. What? 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 Okay. Control C. Sweet baby Thor. I have to do all of this? Oh my gosh. No, that feels wrong. That's like I'm trying too hard for stuff. Oh my gosh. Why? I just want to listen to the space bar. Oh my gosh. Oh look, hold on. Mario, this is exactly how we all feel. Problems? Lol. I don't think you could have said it any better, Mario. I just want to be able to press the space bar to grab the picture. Add key events to window React. Not key down, key up. Yeah, and I don't want the div to be in focus. I just want the whole friggin' window to... There's like a whole Pluralsight course on implementing Or is it just a guide? Oh, it's just a guide. I thought it was a whole course. Keyboard events in React. Handle answer change on key press. This is not what I want. I want to be able to just press the space bar for the whole thing. Keyboard events. Nice. Here we go. Now we're in the official place. The key property focus. React DOM. Should have called it something else. Instead of React DOM, we should have called it React Dumb. React is dumb. Maybe the new React docs will tell us. Learn key events. Separating event from a... Oh my goodness. First, let's recap the difference between event handlers and effects. Imagine you're implementing a chat room component. No, I don't. I just
I just want to have a space button event. Not like outer space, but like the keyboard space. That's all I want. That's it.
my inner child here trying to figure this out. Okay. Synchronizing with effects. You might not need an effect. Life cycle. Oh my gosh. Why is React so dang hard? I wonder if I could just short circuit the whole thing. Window dot on key up equals. I wonder if I do that, will anyone get mad at me? We can take this out. Window on key up. If key equals space, add image. It's like it knew what I wanted to do the whole time. Look at that. I wonder if I need to do this in a use effect. I don't care. Darn you, React. What? What the heck? What doesn't it like? Window is not defined. Oh my gosh. Tell us, Stack Overflow. Ugh. How rude. What's wrong with you? Okay. So how do you add a global key handler in React? This is adding global key key handler React. But how do you do that with a function component? Where's the click being generated from, though? Yes. Yes. Huh? Mm-hmm. Yes. Yeah, I don't know why this is not as easy as I thought it would be. All right, we're gonna have to figure out how to send this to the back end. This to me is absolutely frustrating. Let's see this const handle key. And it turns out that I mean, I guess I could do this on key up equals handle key. But even this didn't like that. I should have closed my Outlook. What if like there was like top secret meeting detailing discussion of plans? Let's try this. Oh, it liked it. Who knew? I just needed to let the AI do the work for me. That's it? Oh my gosh. If that's all it took, I'm going to be so mad. Refresh. It's going to press space. No. So that's not it. It needs to be focused here. I'd love to attach it to the body. Attach event to body in React. AI will replace developers soon? I don't know. I don't know if that's true. And the reason why I say that is because we're not very good at our jobs. How about this? Use effect. document.body.add-event-listener. It's like going to the roots of stuff here, but I wonder how you do the, here we go. There we go. What are the types? Types. Event type. Event types. The freak, where are they? What are the available events? Document. Constructor. Oh my gosh, this is so dumb. All right. Event reference. Animation. Clipboard. Composition. Transition. Database. Drag and drop. Focus. Where's the key ones? H, A, B, C, D, F, G, H, I. Keyboard. Key up. Elliot's telling me it's key up. Let's try it. Thank you. Key up. And we're just going to do this one. And it doesn't like this because I have a typo. Yeah, I fixed that. That was right here. Thanks, Elliot. But this... Event listener. This HTML element, Eve, keyword element. Okay, I think it's element. Oh, jeez. Maybe I should just not type it at all. I guess it's happy. E doesn't have, I think it's key event. Okay. 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 Format document. You don't have access to the handle key because of the closure. Good call. By the way, this is Elliot pair programming with me. What he's saying is this thing is closed over inside of here, but then when this is called, this disappears. So we need to do this. Thank you. Good call, my dude. Okay. You, kind sir, can go away. Oh, jeez. I already have to put on the walk-off music here because we're close to being done. And all I could do was get this stupid thing to show up. Let's see if it works. Woo! All right. It's adding it to the same spot. That's not good. It's doing something though. Okay. Add image. Gets the current ref. Sets the images. Where do we call this from? Go to references. Why isn't it doing that? I think I have to do this. No, this is literally the function I need to call. I need to check if there's a current one, and I need to set the images to what's in there plus the new frame. And this removes it. This works though, so thank you so much to Elliot Sherman, who's a genius. Genius! Thank you, sir. But it feels like this event handler for handling the keyboard event is not adding the image properly. Add image, checks for the current one. Remove image does the right thing. Let's see what happens if we just use the capture. See, this works. Ooh. All right, friends. We're close. That was a little easy method to help me do the right things with this. But next week or next time, we're going to be trying to add. Elliot just finished a boot camp like 2 weeks ago. You are a genius. Thank you, Elliot, for your help. I'm a deep learning expert in machine learning, but I have to do React stuff to make this stuff even useful for people. It's been a delight and a pleasure being with every one of you this week. Next time on the AI Show, Friday, December 2nd, visual search asset with Azure AI. Visual search asset with Azure. Interesting. Serge will be back. He's in France, of course. It's always a privilege being with every one of you. The goal of this show is to have a good time, learn some stuff about AI, and hopefully learn from each other. Thank you so much for being with us, and hopefully we'll see you in 2 weeks, December 2nd, with Serge to talk all about AI, finish our project, and have a rootin' tootin' good time. We'll see you next time. Thanks for watching, and hopefully we'll see you next time. Take care.